Okay, so this is the part 3 video of 4 to prepare you for the mock exam. So we're going to continue and try to get ourselves prepared for the exam. Okay, so you'll be asked a question in question 3. You'll be asked questions about safety, health and safety. Um, there are a selection of tools and equipment that you could use in product design. I suggest you study the health and safety rules for these particular tools that I have identified. So the first one would be soldering iron, okay, and always wear safety glasses when soldering would be one of the safety rules. Solder in a well ventilated space, so lots of air. You would also want to put your iron back into the stand when you've finished using it. You would also never place the soldering iron on a work surface when it's on. Okay, always place it back in the holder. Never touch the tip of a hot soldering iron. Be sure to unplug after use, okay, and leave it to cool down. The next tool would be a pillar drill. Always wear goggles. Check guard to see if it's fitted. And when you're drilling in place, you can actually use the guard. So there will be a guard around here. So you can see that yellow part there. That's the rim of the guard. It's usually see through. And then check to know where the emergency stops are. So usually there's an emergency stop over here. There might be a foot stop. Usually there is in schools on the floor or in a workshop. Usually there's a foot stop on the floor as well. Okay, so you can operate with your foot. Make sure that all long hair is tied back. You have no tie, or if you have a tie, you tuck it behind your apron. Okay, to avoid it from getting entangled around the chuck or any other spinning parts. When you've finished, switch off the machine and switch off at the wall, at the mains as well. Clean down any dust that's left over. Okay, ensure that the chuck key that's used to open up the chuck isn't left in here when you're operating. It's placed back in its holder. So those are the safety rules for a pillar drill. And then for using a vacuum former, these are the possible hazards. Okay, so there could be electrical shocks, there could be burns, okay, from using it. Okay, so the person who could be at risk could be the person using the machine. Electrical shocks, once again, the person using the machine. This could cause an explosion. So what are the things to stop that? So regular maintenance, electrical survey would be needed. So when using it, obviously don't touch any hot parts. You should all be reminded that this part over here is very hot, so you wouldn't put your hands there, and the fact that underneath here is a heating element, so that's also quite dangerous. So those are the safety rules that you have to follow. Make sure that you keep an eye on the vacuum former in case it catches fire. Okay, there's no paper or any other types of flammable material or other types of substances left around the vacuum former while it's working or when it's on. So those are the kind of safety rules that you could put down, and those are the potential hazards. Okay. Now going back again, potential hazards for this could be your hair could get tied up around here, any long parts of your tie could get tied up around here. So you've got to be very careful and identify the kind of hazards that could happen. If you don't secure your work on top of the platform or the platen over here, as you drill into the work, it will fall off, or it could get caught up as well and be thrown across the room. So that's a potential hazard as well. With this as well, if you touch the tip or if you leave it on a work surface, the hazard could be that it can cause a fire. Okay, so let's move on. So we've covered now health and safety and potential hazards for that. Okay, now product safety is very, very important. So these are the kind of symbols that you're likely to come across in product design exams. So the line mark is issued by the British Toys Association, and this is an age warning. So basically what it is you're not allowed to give a product, or the product is not suitable for children between the ages of 0 to 3 years of age, usually because of a choke hazard. This line mark, going back to the line mark, the British Hobbies and Toys Association issues this when a product meets all the safety standards and meets a standard of quality. Then it has the British line mark. It has a line mark on it. Now this is issued by, this is the kite mark, is issued by the British Standards Institute, and identifies products where safety is very important, such as crash helmets, smoke alarms, and flood defenses. So these symbols would actually be on those. Also, there are other products which have similar kite marks, which mean like they've reached like standards of quality. Okay, and then this is the European conformity symbol. It basically means that the product conforms to European standards. It doesn't necessarily mean that it's totally safe. Okay, so that's what these symbols mean. And then consumer protection. So government, parliament has produced rules, legislature, which is called, or legislation, which protects consumers. So designers and manufacturers have to make sure that their products meet these standards. So one of those would be Sale and Supply of Goods Act 1994. That says that all products must be of satisfactory quality. This means that they have to be safe, last for a reasonable amount of time, be fit for their use, for their purpose. So if they say they're supposed to be, let's say for example, supposed to be a tire, and it's meant to last for 2 or 3 years, and on a car, then it's meant to last for 2 or 3 years, and it should be able to run as a tire. There's nothing wrong with them. There are no defects. Okay, when it was sold at the point of sale. So these are the kind of protection that is given to consumers by the Sale and Supply of Goods Act 1994. Then there's the Trade Descriptions Act as well. So this basically bars manufacturers from selling products with false or misleading information. Okay, so for example, accurate information must be given about who made the product, for example. So fake designer goods should not be marketed as genuine, as this is like a breach of the Trade Descriptions Act. Consumer Rights Act 2015 is the most up-to-date, and actually it kind of supersedes it. It takes over. Supersede means that it takes over. It's above some of the previous parts of the Trade Descriptions Act and Sale and Supply of Goods Act and other acts as well. And basically what it does is it kind of fills in all the gaps that the others haven't covered. So for example, you're protected for failed repairs. You can go back again and ask for another repair if it's done. If it's not repaired, then you get a replacement after the second repair. You can have there shouldn't be any deductions from refunds. You have rights for digital content. So if you download something, it doesn't work properly, then you have rights to get your money back. For example, you have 30 days to get a refund. So it covers some of these. There's other parts as well that it covers, but you would have to look it up yourself on the internet. If you look on Wikipedia, you're probably able to find a lot more information. So now question 4 is about batch production. So batch production is a process where you make products in 12s to up to 10 to up to thousands to up to 10,000 batches. Okay, and usually these are the type of tools that are used to speed up the process. So let's say, for example, we're making packaging. We would use a die, so like a biscuit cutter. So in the shape of a biscuit cutter, you can then use a die to punch a hole in card or material. Another type of tool that is used in batch production would be a jig. So basically a jig, for example, this is a jig for following the same elephant theme. This is a jig where what it does is it's a tool that's made just to do one job. That's what a jig is. It's a tool that is made to do just one job. So 2 types of jigs. This is a drilling jig. So you got a hole in there, and if you place it over the elephant shape there, you can then drill in the same place over and over again. This is a cutting jig. So you, for example, let's say you're cutting the size of a box. You push it in there into this particular section here, and because this is the right length, when you cut here, you will always pretty much get the same lengths, give or take a few millimeters. Okay, so that's what a jig is. A jig is a tool that's made to do one particular or one specific job. A template is basically an outline of a shape, and it's used to draw around so you can cut something out. A mold is like, it's like basically a hollowing out of a piece of material. So let's say, for example, I wanted to make a metal elephant, a cast metal elephant. I could melt the metal so it's in liquid form, and then pour it into this mold. And then when the metal cools down, it will take the shape of the mold. Okay, so I have a positive, which is what I want, from the negative, which is the cutout in the mold. And then the former is basically like a positive shape, as you can see. And then what you do is you can place this, for example, inside a vacuum former. This could be soft plastic, and then you can form the plastic around the former so you get a positive shape. Okay, so let's move on now to the next part. So let's say, for example, I'm in a school workshop and I'm making wooden toys. What I would, first of all, I might get a template. I will then draw around the template onto maybe some sheet plastic or sheet plywood. Okay, so I'll draw around it, then I'll pass it on to the next person in the next station, who would then cut around the elephant shape. Or I could use a fret saw, which is a lot quicker. The fret saw will cut it all around. I would then have someone who is here doing quality control, if it's not, even I haven't shown it here, who would actually check to make sure that the outline has been cut properly. Then it will be given to the next person, who would then sand the sides down. We would then drill the holes using a template, once again, for the elephant shape for the toy. And then someone would then, once again, do quality control over here. They will then clean it all up before then someone then paints the outside, paints the outside, or the gets a finish to the shape. And then let's say, for example, we wanted to fit a component in. Let's say, for example, it was a clock. We could then fit the clock to the bottom and then fit the hands on top. Okay, so that's how you could do a batch production process in a school workshop. This is how you would set it up. Let's say, for example, you're making a toy. So rather than actually it being a clock, it could just easily be a toy as well. The same process applies for pretty much most products which are made from sheet materials like metal, plastic, man-made boards like plywood, chipboard. Okay, so you could actually use this process of marking out, cutting, okay, finishing up or sanding, wasting away, drilling, finishing the surface, cleaning it up. Always make sure you got quality control. You're checking at each stage to make sure it's been made to a high standard, and then adding components at the end, adding standard components you can buy off the shelf. A standard component is a component that's basically been made, it's been standardized, so it's always the same shape, and it conforms to some rules or safety rules around the world, and it can be bought off the shelf. Like, for example, like screws. Screws are standard components. You can buy them anywhere. They do the same thing. They're pretty much the same size and so on, and they fit a particular standard. Okay, so let's move to the next one. So this is, for example, this is for doing a photo frame. Okay, once again, same process, marking out, then cutting it out, or laser cutting. You can use a laser cutter. Then afterwards, you'll drill holes to finish it off. You will then maybe finish off with a file because it's plastic, or with emery cloth, or wet and dry the edges to finish off to give it a good finish. You might then buff it, glue it together, and assemble it. Okay, so once again, same process: marking out, cutting, wasting, finishing, assembly, standard components. Once again, so follow that process. Okay, so next one. So now this is a more complicated one, but it's the same process. So this involves using casting, which will then use a mold, as we talked about earlier on, packaging, So if you're cutting out the outside of a for packaging, you would use a die cutter. So there'll be a die inside underneath it, like a biscuit cutter. When you push the lever over this, it forces this down and cuts into the card. Okay. So a vacuum former, use a former that goes inside a vacuum forming machine. You can form material around it. Okay, and then someone would assemble this over here and place the cast elephant inside of the packaging. So we've used different types of aids. So we used over here, we used a mold, we used a die, we used a former, and over here we've assembled everything to put together using all those different processes that we used to make these different parts for the product. And then so you could organize it all pretty much like this, and then possibly you'll staple it together. In the workshop, this is what you would actually do. So this is how you could possibly organize how you would make something in a workshop. So you have a quality control part over here. You have the processes being made. Someone will be at each stage of these. Okay, so let's say for example making a metal elephant out of pewter, which is an alloy of metals, which contains copper, antimony, and tin. And what you would then do is you would have a person for each stage working on each stage. There'll be someone who's doing quality control. Okay, and then over here, as you can see, and then the whole process would end up with the finished product. So pretty much it's like the same, the one before, but this is more colorful and a lot easier to understand. So the whole point about the batch production question is you're trying to identify the different types of job aids. They're called job aids that can be used to make a product. So you got a template, you have a die, you have a jig, you have a mold, you have a former. Then you would actually show the process of making that particular product, not forgetting quality control, okay, which is very important for each stage to make sure that the product is made at a high standard. And there will actually be maybe 2 or 3 people for each particular stage over here. Okay, so you need to make sure that you talk about these things for each stage, and you show maybe a drawing or maybe just boxes with labels inside of them with arrows showing the process of what you're trying to do. Okay, so this concludes part 3. Okay, so part 4 will follow shortly.